Hello and welcome to Mastering the Basics with Pandas. Now, Pandas is a fantastic and robust package that we can use with Python in conjunction with Python. It's a Python package, and all it stands for is panel data. So think of Excel sheets, Google Sheets, just panel data, rows, columns, stuff like that. We're going to jump into and do a code along with Pandas to understand series and data frames and a number of things. We're going to retrieve data, clean data, and really start to uncover the capabilities of working with Pandas in Python. And for this code along, I've created a Jupyter notebook, and I've uploaded it to GitHub, and I'll post that link in the description in below if you want to download this Jupyter notebook off GitHub. If you don't know what Jupyter Notebooks are, I have a series on Jupyter Notebooks and how to download that onto your machine. But check out my GitHub page, and you can follow along and code along with the code I have up there, posted up there. All right, so let's dive over into our Jupyter Notebook. And I already have some code written out there. And the first code I have written out here is just a dictionary. So if you're familiar with Python code, you're probably pretty familiar with dictionaries and how they work. Dictionaries work, you name your dictionary like you would name a variable, so you can always call that, and then you name a key and a value. Dictionaries work on keys and values, and ideally all your keys would be the same and all your values would be different, and so you would have this library of data of dictionaries, and you can, based on your conventional key naming, you could pick different values. So employee 1, you can pick employee 1's title. So I just created a random person here, employee 1, dictionary of employee 1, and if we wanted to pull employee 1's name, Bob Dugooder. So just think of this on a very large scale of employees at a few hundred person company or whatever, 10,000 person company, what have you, and you needed to access them. Very easy way to do that within dictionaries. You can write loops in dictionaries, but in Pandas, working with series is much more intuitive, and it's a much better way to work with key and value items, and then it also lends itself to working extremely well with data frames, and it's all built on the NumPy package, which I also have videos on. And please go check those out because everything here is building on each other. NumPy builds on, or Python, we need an understanding of Python, you need an understanding of NumPy, and then we can just continue to build on top of that with Pandas. So without further ado, let's start coding in Pandas, in Python using Pandas. So let's import Pandas, and we always import Pandas as PD. PD is just the conventional naming for Pandas. The term that's makes your code readable to other people, and people know what you're doing and saying when you're sharing code with other people. So let's just create a series. So a series, that's why I had this example of a dictionary, because I'm going to show you why a series is better. So let's name this new series basic. It's going to be a basic series, and calling a Pandas series, and series is capitalized, and the way you name a series is open parentheses, open bracket, and now we have, and then your items need commas between them, and my name, Jules, and Anne. Alright, and let's print basic. Cool. So it's going to take a second there because it's going to import the Pandas series. It's going to import the Pandas package and then create our series, and boom, it's going to spit out our key and value. So our key, it's going to automatically create those keys for us, 0, 1, 2, those indexes. It works just like the indexes that we talked about in NumPy. We could easily call our values by just calling our keys, and I can show you how to do that. So we just type our series, and we want to slice it. Slicing is something I talked about earlier in our NumPy video. We're going to slice it based on the indexed values, so we just want those first two items, and whoops, let's Shift Enter to run that cell. Look at that. We have the first two items based on our slicing there. So keys and values still work the same way. We can, like in a dictionary, you name your key. If you don't like the 0 and on and on and on index, then you can name your index whatever you want. You can name your key whatever you want. And so these are employees. So let's just name them employees. So we're going to create an index, and that index is going to be equal to employee 1 and employee 2 and we'll have employee 3. And we need to append that now to our list, so we need to, or our series, we're going to name our series. And then we want to say that is equal to the index, and let's print that out. Shift Enter, run that cell. Now look what we have. We've changed our key values now. So now we have, it's listed out employee 1, employee 2, employee 3, and our values have now stayed the same. So, but a really cool thing is that we still have the ability to call our items based on the underlying indexed values. So slicing still works the same way. So now we can still call Bob, or we can call Bob by his employee key. Well, I am sorry. So you still need the, did not put those in quotes. There we go. So now you can still call based on the keys. And just remember, when you have strings, you need to put quotation marks around them. So that's through and through Python in general, and that's not special to Pandas, and I should have known that. So you can still use the underlying index numbers, or you can use the keys, the indices that you've now named. So both still work, and that is really cool, and it's a really awesome thing about Pandas series. So that's a series. Learning and understanding series is just going to lend itself to understanding data frames, which is really where the work and really where the cool data analysis comes into play. So let's start here and create a random data frame. Let's create let's really get into it and create a data frame here. And we're going to use a data frame by using our favorite package, NumPy. Alright, remember, if you want to refresh on NumPy, I have a 2-part series on learning NumPy. Getting beyond the basics of NumPy is what that's called on my YouTube channel, so feel free to check that out. Alright, so data frame. Let's just camp on this just for 1 second. When we're creating data frames, you always call pandas so pd dot data frame, capital D, capital F, and we are going to use the NumPy. We're really familiar with this one. The random dot randint function, and let's get a series of numbers between 1 and 100, between 0 and 100. And now we want to name the size of our data frame, and so we always list the rows and then the columns. So let's do 10 columns by 4 rows, and now let's index the rows. So if we didn't do this, it would just spit out a random index, just like the series did, starting at 0 and then just count. But let's get a little creative with it and multiply that by 10. Yeah, so just to create some variety in our data set. So we're going to name the index list. We're going to list out here 0, 10, 20, 30, 40, 50, 60, 70, and we need, so we have 10 rows, so let's name that. And then we want to name the columns as well. So I'm a terrible speller. Columns are, then we'll just name those A, B, C, D. So columns equal list. Let's A, B, C, D. Okay. And we want to see what we just created there. So let's print our data frame. Oh no. Let's see where we messed up. Name size is not defined. Oh, I need the equal sign there. Sorry about that. That should work now. Cool. Awesome. Now we have our data frame that we've created. We want to call, so remember the lock and iLock, I touched on that before. When we use the lock and iLock methods, that is going to be able to, that we're going to retrieve an entire row. So lock is going to use this row key, and we just want to call row index 50. What do we got there? So looking at 50, it's going to retrieve all the data in that indexed row. So if we got 55, 42, 32, 53, and that's what we have there. And name 50 is going to tell us our type, integer. Cool. Very, very cool stuff. We can also use the iLock there, and when we use iLock, we have to use the underlying index number. So we're not going to use the key necessarily. We are just going to use whatever, and so let's call the second index number, and that's, let's go look back up here at our data frame. We have 0, 1, 2, so 20 is going to be that row name, but it's going to be index number 2, so it should return 61, 27, 45, and 58. There it is, name 20. So we called the second index, and it even returns, hey, this is the column, this is the row name for you. So very cool stuff. Let's print out that data frame one more time so we can just reference it pretty easily for us down here on our screen. And now a big thing with data and working with data, manipulating data, cleaning data is working with null values. And so there are a number of ways to check for null values. One fun and cool way is not null, and you probably are not going to want to do this if you have a very large data set, because you are going to get your data set printed out and it's just going to be a Boolean expression, either a true or false expression for every single data item, whether if it is or not null. So we created this data frame to be full and to have no null values. Null values meaning nothing. Null is just means nothing essentially. We have data in every single column and row. But it's really important to learn how to deal with null values, so we're going to impute a null value just for demonstration's sake. You will probably never want to impute a null value, but you're probably going to have data with null values, so we're going to have to learn how to deal with that. So let's just, for demonstration's sake, let's insert a null value. So let's go, we're going to call lock, and we want to name one value in our data set. So let's go row 30, item under column C. C. And we're going to make that, this is actually really funny, npn, and so funny just imputing null data into your data set. Okay, so now if we print df, we are going to have a null value, and then null value is not a number, so it's going to tell us not a number. We have our null value now where we specified to have that null value. So we can check the percentage. So say we had this data, we were given this data set, and one of the first things you're going to want to do is you want to check for null values, and a fun and easy way to do that is name your data set is null, and you want to see what percentage of columns have null values. So I want to say mean times 100, and this is going to print out, whoops, oh sorry, so is null, end that expression, and then we want the mean equal to 100. And then it's going to print out all of our columns and what percentage of those columns have null value. So we have 10 columns, one of those values is null, and so that's 10% of column C is null. And so In some instances, in a data set like this, where we just have a few null values, it might be okay. You're going to be the judge of this. It might be okay just to drop an entire row, because machine learning might get a little hairy. You might want to just drop all your null values from your data. So we can name the new data frame is equal to data frame dot drop NA. We want to drop all our null values on axis 0, meaning so on the row axis, because we could also specify the column axis. It's all depending on how your data is structured. And this, as the data scientist, these are the questions you're going to need to answer. And how is an argument. We're saying if there are any null values in any row, drop that data. Drop it like it's hot. And then so we want to print that new data frame just to check out our data. And now look, it goes index 0, 10, 20. There's no 30 because there was a null value. We imputed that null value into the row 30, and it just completely dropped it. So that's a really cool way to deal with null values. I want to keep these videos short, and so I'm going to end it here. I will continue talking about pandas, but in our next video, and get into some more meaningful and cool analysis with data frames. So I'll see you in our next video.